Okay, we've got quite a few of you in. So what we'll do, we'll jump straight in. So thanks all for coming today. Really appreciate you taking the time to come down and learn from Andrew and WeShape. So what we'll do, we'll jump into a quick introduction to WeShape, and then I'll pass over to Andrew to do all the fun stuff afterwards. So, Andrew, if you want to take us through to the next slide, then hopefully you've all heard of WeShape. So WeShape, we're a technology consultancy. We're very uniquely placed in terms of our setup between ex-industry technology recruiters and technical consultants. So it just gives us that flexibility to be able to identify and solve your technical pain points quickly using our our flexible associate network to come in. Now, the website can do obviously a lot better of explaining it than me. So in classic COVID fashion, we've got that QR code there. So feel free to scan that through and visit our website and find out more. Andrew, if you'd like to click through. So in terms of WeShape, what we offer, so organizational technical advisory. So this is where we can really add value to your organization by coming in and running similar workshops to what you're about to see today, where we come in on a usually sort of 1 week basis with one of our lead project consultants like Andrew to identify those pain points that you're facing in your organization, whether that's technical or organizational, and effectively plan out a plan of action to solve those technical issues. Squad implementation. So we've done this with a number of our customers now, where they require large-scale technology change, and we can rapidly turn around teams in 48 hours to come in and solve those technical pain points. Very similar to SME consultants. So these are flexible, on-demand consultants, uniquely placed to solve your unique challenges. And then finally, we can offer training and coaching. So again, a lot more bespoke. So we'll send in a consultant to put together a bespoke training and coaching plan for your business, again, specifically around your technical pain points. So, Andrew, if you want to take us through to the next slide. And then what sets us apart as well is our communities. So hopefully you've all heard of London Tech Leaders, which is our C-suite network. Love to see you all down there. We're hosting an in-person event on the 5th of August. So do make sure to check in with our team afterwards to get your invite. We'll be on the London rooftop, open bar, and what more could you want in the middle of August. And then London DevOps is our more technology-focused community. So we've got 8,000 open source specialists. So as an employer, Marion, we will be we'll be sending around a recording of this afterwards. So London DevOps, again, open source specialists. It's great for both your teams to attend because they'll be learning from some thought leaders in all those areas, but also from yourself. So if you're hiring DevOps specialists at the moment, do let us know. And it's a great opportunity to come down, present, and basically present what you're doing better than everyone else, and hopefully take away some ideas after this workshop to go and talk about as well. But Andrew, so if you want to let us through. And then finally, just in terms of our focus, so again, WeShape was set up to solve the issues of land and expand consultancies, permanent benches where you might get consultants that are just not SMEs, or trying to fit a square peg in a round hole effectively. So WeShape was specifically set up to be flexible and rapid. That's where our blended approach of ex-technology recruiters and technical consultants really comes into play to help guide your technology strategy, accelerate your product technical delivery through paired project teams, so our consultants sitting side by side. And again, that knowledge transfer, we're not interested in land and expand. We want all of our customers to be fully self-sufficient when we roll off. And that's exactly why in all of our engagements, we combine, again, process tool methodologies, paired teams, and knowledge transfer to ensure all of our customers are completely self-sufficient. And next slide, Andrew, if that's right. So yeah, what I'll do now, luckily enough for you, you'll finish hearing me talk, and I'll pass over to Andrew Southall, who's our lead project consultant, really experienced, and I'll let him talk through all things SRE and give you a high-level overview of the benefits. But again, best man to introduce you to Andrew is Andrew. So I'll pass you over now. Thanks all.
Brilliant, thanks for that, Pat. So yes, I'm Andrew Southall. I'm one of the lead consultants at WeShape, working on a number of projects across very, very disparate projects at the moment. WeShape's got quite a lot of different things that they're able to add expertise to. And that leads to some really, really interesting situations. But there's also quite a common theme throughout a lot of it. A lot of it's focused on automation. A lot of it's actually really around implementing technology to make our clients' teams operate better, and in a way also just have a better working environment as well, which is where system reliability engineering comes in. So this is it's my experience as an SRE, which I've been doing for a number of years, but I'll go over that in a second. It's a presentation kind of introducing the concept and the ideas and what it really practically is, because a lot of the times system reliability engineering gets shoved in under DevOps, and they just do what DevOps engineers do, which is just automate stuff without really an overriding strategy or really that much of a discipline, serious discipline behind it, just a vague direction to which you work towards. So with that in mind, I'm going to be covering a few bits and pieces here. I'm just going to be making it really clear up front that a big focus of SRE is actually quite highly tailoring what you need to do or what you would like to do in your organization to your organization. That middle word, reliability, is very, very contextual. So what is reliable for me might not be reliable for you, or you might even have other things which are in fact highly, you need to rely on them massively. They need to be highly reliable, but they're not even considered or part of your overall plan. So this will be a quite high level talk, but I will break it down into some examples to give some meat to the ideas behind SRE. So who am I? I'll go over that first, and then we'll go into definition of SRE. We'll talk about where it sits in your organization, how it sits, that's where the meat comes onto the bones, some ideal, some less ideal examples, some amazing examples of where this should really go for your organization, and then some final notes. So, Andrew Southall, obviously full stack developer. I've been doing this for well over 10 years now, and that 10 years has taken me through providing regulatory APIs, banking systems, media groups, and a lot of highly available applications, whether that just needs to be highly available because it's the primary source of revenue, or whether the government or government agencies are telling you to literally make it highly available, otherwise there will be investigations and you'll be in a lot of trouble. So the largest that I've taken care of in terms of keeping reliable is probably open banking APIs, but not just for the UK, also for Mexico, Australia, Hong Kong, a number of other areas, and that's been the largest so far. But overall, it's all been quite meaty stuff that's been incredibly critically important to the organizations in which I've worked at, because they've been taking care of payments, they've been taking care of real life user logins. PI has played a massive part in what I've done. So when we consider an SRE, that's a lot of good experience that I'm bringing to other places, and hopefully while this little workshop will be quite fruitful for you folks. So defining SRE is quite important, because yes, it's got a tailored aspect to what you do, but we all start from the same point. And essentially it's all about reliability, which I've already mentioned. That middle word really dominates everything. It's got a number of different names. Google refers to it as site reliability engineering, which kind of shows what they were interested in. They were interested in keeping their site or sites reliably up. You find other ones as well. Some people just refer to it as SysOps, systems admin, way back from when most companies were basically just office admin. You need to keep the Exchange server up. But overall, its systems is a better way to capture everything, because it doesn't just capture your applications or your other really standout IT star stuff. It can also capture really cross-industry things. So you would find things or processes like system reliability engineering in areas such as aviation, which has been hugely successful in that. You'll find it in other mechanical areas. It's an engineering role, so it's cross-discipline. And the reliability part is really about making sure that whatever happens is dealt with. So you examine your risks, your methodologies, what could go wrong, and you build safeguards around it such that if anything does go wrong, it reliably fails, and you can end up relying on that system, whatever it is, whether it's a plane, whether it's a car, whether it's a great big huge website application or whatever. You can rely on it to do what it needs to do, and it's not just going to unexpectedly fail or leave you in a position where there's a lot of anxiety and problems with that system. And this comes from a lot of different elements that go into it. So how do we want it to fail? How do we deal with failure? Do we have run books? Do we want the system to try, or do we want it to catastrophically fail before it goes ahead? And that's where the engineering aspect comes in. So reliability is fairly human, but the engineering element is a lot more, we'll call it binary, digital, yes or no. It either does or it doesn't. So that's where you end up having to put in a lot of processes, systems, and really a lot of quite solid discipline. There's very little variation on it. It's true engineering. So you've got to have your boundaries to know whether you're operating inside or outside those boundaries, and you've got to, and with that, you have to define what's dependable for you. So with that in mind, adopting SRE is not about just giving a title to a few DevOps engineers to make the systems go up a lot more. It's actually a lot about process and standards. So how do we define our reliability? We have to know what we're doing. We have to be happy with it, and we have to be able to quantify what we want to do. And then we also have to take ownership of bringing that reality about. So one of the biggest phrases that comes out of Google's SRE books is hope is not a strategy, which is quite a challenging phrase. And I pick it out, yes, because you Google this term, you'll get all the information, all the discussion about it. So that's one element where it's useful to know. But also it's quite a combative phrase. It's a phrase that you would pull out when you're going through design reviews and really challenging to make sure that things are reliable. And that, I think that really embodies probably some of the biggest challenges that you get with SRE, which is people think they're automating stuff, they think it looks good, the dashboards are okay, but then your metrics are just not being picked up, or you can't actually rely on the dashboards because everything says it's all okay, but everything's down. And that affects some of the largest companies. Amazon is a great example where they had the large-scale S3 outage a few years ago, and because their dashboard for the status was, I believe it was just a HTML page hosted on S3, it was cached because S3 was down, couldn't be updated, and so said everything was fine, despite everything was categorically not fine. So now you can't rely on the dashboards anymore. So that's a very strong failure at the discipline and enforcement of standards approach. You cannot reliably uptime the system and rely on that uptime monitoring if it's a circular dependency within itself. So that's some of the really big aspects. This is not about automation. Automation plays a big part, it's a tool, but really it's about getting down to the nitty-gritty discipline, really staying within your lane, making sure that you know your knowns, you know your unknowns, and that you've accommodated as much as possible. So with all of that high level stuff in mind, that's all quite theoretic. You probably feel like you're on a coaching course or something else. I'm going to talk about more practical elements. And with that in mind, obviously I've said it's cross-discipline, so you will find reliability engineering elsewhere. But given the context of WeShape and where they work, the vast majority of what we do is IT, software, DevOps, and things like that. So we'll talk with that context in mind. And where I find SRE really fitting into a organization is as its own entity. And that's because you can get DevOps engineers embedded in a production team, application team, and a lot of the time that's quite a good place for them. But the dynamics of that situation works against SRE, because as I've mentioned, SRE is quite, it can be quite a combative, not even so much combative, but it's quite unrelenting, it's unyielding. And if you are part of a team That by your definition means that you have to go with the team. So having an SRE engineer sitting inside a team often gets pulled into the core purpose of that team, which is usually feature delivery, getting things out the door, and an environment which is more about delivering consistent functionality and less about engineering a better process. So I've never seen it really work that well in that entity. What you have there is an embedded DevOps engineer who essentially works across the team to encourage automation, to get automation done. Good role isn't SRE. And the other important element of this is, with this being engineering, your engineering is quite important as well, because engineering is all about getting repeatable, consistent patterns. And when you're inside a team, especially a team which is mostly feature delivery, you're doing something different, ever so slightly different all the time. It's very easy to automate out that, and then you come onto unique features, and every feature is not going to be quite the same as the others. So really, SRE works in a system where it's across an organization, as opposed to within individual application delivery pieces. And as well as that, I would say that being able to actively enforce elements means that really, with most hierarchical organization structures, this needs to be sitting over the top in order to properly enforce those standards. A bit like security has its gatekeeping, you want your SREs to provide the similar gatekeeping, which might even be within the same team, might be in the same area, might be the same responsibility. Thus, that's why I would put security as a responsibility generally go to your principal engineering or your development managers. SRE would go directly alongside that as well. You can't be rolling out systems which don't have health checks on them, so that monitoring software can't pick it up. That's a fundamental failure of development management and principal engineering. You can't have hard-coded passwords and other things, and the same things that was set up for security. You can't get that with SRE either. Your code needs to be captured. You can't just have random files and conflict things hanging around. So it's really about that discipline, and that discipline has to come from the top. What you will find in this context of SRE within software delivery is that you'll find very, very common tools, something to handle your monitoring, your logging, security scanning, to make sure that reliably you are updated with your software. You can rely on the fact that your software is secure. That comes under a similar aspect, although we know security is its own practice. You would take the same approach to it. Everything, for example, everything has to go through, say, a sneak or something else. And then you get your application analytics and your internal IAM to make sure that the right people have the right access to things. And that includes your pipelines as well. So there's a number of different areas, very, very common tools. I've provided some common tools here. These are some of the ones that you would find out there, which are quite popular, but it's whatever works for you. If you're not doing any logs or not many logs, then obviously you can pick and choose as you like. Use AWS CloudWatch or other things like that. Very, very tailored towards you. But those are common areas for software SREs. And to be reliable, we have all of this engineering coming back into it. So this is once again reflecting the fact that in software, we want to make sure that we are providing that reliability engineering. So we're picking up on the constant patterns across the teams. We're making sure that we've got any self-healing as we want it, if they want to fail immediately, and working that out, condensing it down, getting documentation out, and a lot of stuff which is a lot of work to begin with, but once it's implemented, once it's put out, once it's enforced, we end up with that reliability that we're after. So let's talk about some ideal and less ideal scenarios, just to really concrete out what SRE is. So we'll talk about a less ideal situation. All of these are real life examples, but I won't be sharing any client information. They're going to stay quite high level, but you'll still get the value of knowing the details. So we've got a technology company who is providing a application to clients. They are relatively medium sized. They've been doing it for a little while, but because they're a younger company, they're not dealing with a heritage of debt. So they've got a dedicated SRE team. Beautiful. They've got scalable monitoring. They're using a Prometheus operator in their Kubernetes cluster, which scales with the number of applications. And whilst you log onto the Prometheus screen, it crashes your browser because it's got so many metrics. It still allows for the rest of Grafana to pick up. Application teams can get the metrics that they're after, and you can build up beautiful diagrams that really show things. And the alerting's there. It's all integrated with alerting systems. Great, fantastic. That sounds like SRE. Additionally, because the SRE team is now treated independently, they're not getting bogged down with feature development. The problem is the SRE team is getting absolutely battered with day-to-day toil. And toil is it's a word that's defined in Google's SRE book. I keep coming back to the Google SRE books because it's one of the big first SRE practice books that define it. They keep getting basically third-line support. So if they've got a deployment and the deployment's a bit gnarly, or they'll always have a reserve SRE for this said deployment, eventually you just pack out the team. And as the client base would have grown, you've ended up with the SRE team spending well over 150% capacity just dealing with deployments, issues, things that have come up, and it's always a quick fix. And the quick fix means you're just pushing the technical debt further and further down the road. They're not doing any engineering, they're doing tech support. So that's a real problem. But the worst part is, and this is where I feel like it's particularly bad, is the fact that because they're the SRE team, the concept is that they're basically just a crutch for everyone else. This isn't reliable, and it's not reliable because it's got a load of hand crank stuff in it, or we haven't got this open, so we've applied a patch. They're actually just there to make it reliable in a very, very brutalist sort of manner. This is broken, you fix it, then it will be reliable. That's not what we're talking about, because there's no engineering in there. You're just throwing resource at stuff just to try and get it to work again. So the rest of the organization just weighs on top of that. And before you know it, you can't do anything in any decent environment without an SRE that you've had to pull out of engineering or doing something to fix a long-term solution to do really, really tedious things for you. So overall, not a nice place to be. And they've had 100% plus turnover in their SRE team annually. They've had clients that have turned around and said, we want to put everything on hold because we can't rely on your systems and services. And then when it comes to fixing stuff, instead of going through the overall process of we pick it up at the incoming issue, incoming problem, okay, we can go back and fix it now and then release it. You get issue, release, patch, forget about it, come back to it, recalibrate, refix, redeploy, and that timeline is significantly larger. So you end up finding that your application teams were really managing their patches more than their features. And that took away the ability for them to get a good velocity out of their teams. We'll talk about another one. This one's more popular, actually. I'll tell you who it is at the end. Had monitoring, had a backup process, had runbooks. Brilliant. And we know this because this particular company is very, very open with what they're dealing with. So they had all that up. They showed it. The only problem was they hadn't actually tested their backups. They didn't rely on the backups. They weren't reliable. They just kind of went through the motions, and they didn't go to a point where they can go, oh, there's backups, it's fine, but do we know that they work? Can we rely on those backups? Additionally, as well, they hadn't built their alerts in a way that they can rely on the alerts. And alerting is really interesting. I'll come back around to it in a second. But the alerting and making sure that your alerts are, one, viable, but also two, not just alerting you, but alerting you to the fact there's no alerts. Like, come back around to that in a second, but that's important too. And then also they've had issues, the classic issues with, databases fail over and they think, well, there's two databases, it's all okay. They hadn't gone through a proper process of going, okay, if our data center is hit by a bomb, will this all work? Because they hadn't done all of that, they couldn't answer the question of, we can reliably do all of this. We know what we know what we don't know, and we're prepared. The company, whose GitLab, lost 6 hours of new users, repos, projects, and more when one of their engineers accidentally wiped the production database. So this was a big one. I'm sure folks know about it, but these points all came out of their retrospective and they had to admit it. They had to do FAQs and all the other elements, and 6 hours was the best case scenario, because prior to wiping the production DB, the engineer in question took a manual backup. So this is after the 6 hours of downtime, and it would have been even longer because their backups were only going on for once every 24 hours, which once again shows that if they did have a catastrophe, in this case, it was a manually kicked off catastrophe. But if it was a catastrophe from elsewhere, they would have lost potentially even more. So those processes and standards to go, right, as a company, what do we want our retrieval process to be? Have we done that process? Can we reliably rebuild? Is really important. And everything I've been saying so far, I think it'd be nicely summarized in GitLab's own words, where they had an FAQ, and it was, why was the backup procedure not tested on a regular basis? Because there was no ownership, and as a result, nobody was responsible for testing this procedure. And this comes back to GitLab have a number of engineers who are busy with general tickets, and they do not have, or did not have at the time, someone that had ownership of the reliability of services, backups, and that element, who could enforce it. And I couldn't put this any better myself. Ownership, discipline, and ensuring that you can actually rely on whatever you need to rely on. So let's move over to a happier place. Let's talk about the ideal. The answer to the question, do I know this system is reliable? You want to answer yes, but you don't want to go, yeah, probably. You want to answer it with substance, objective substance. Yes, I know it's reliable because we test it continuously. And if it fails, because we've tested it so heavily, it's now actually quite an interesting engineering solution, and not just something tedious such as a certificate failed. We have to go through the toil of fixing it. We've got network open, we've been hacked, it was via a patch that we didn't update. You can rely on this because you test it continuously. We've documented everything. We actually know we rebuild it from scratch every week. So if the whole of Ireland just cut the power cord and just got rid of it, and the whole of Amazon in Ireland went down, we could rebuild it in London, or maybe even onto a different cloud provider. And we know that because we did it last Tuesday. Our monitoring and alerting confirms when things are online or offline, and we can rely on it because we build up our systems, hook up new monitoring, and then take it down and make sure the alerts work. And the biggest part is we've done this. I could sign my name up against it. If it doesn't work, if there's something wrong, we've got a history, we've got a pattern, and we can correct those problems. And this is a bit similar to the idea of putting a black box in a plane. Black box reports everything, and potentially there's an element there of going like, look, this was wrong, this person, we need to correct that person, or potentially even capture something, but also it's picking up the lessons that you can learn. So we've got to have our ownership. We've got to have ownership over common areas that will work for your organization, but there's going to be common things like backups, monitoring, recovery. And then we need to have those standards. We need to be able to say, if anything goes wrong, our client base wants us to get back online within 1 or 2 hours. And that needs to be the standard. And you have to meet that standard. You can't just keep compromising or letting 1 or 2 things through, because unenforced standards are just not standards. They're guidelines, which still would result in this situation. That's more of a guideline situation. They did have backups, but it didn't work. Their alerting system, their backups failed, and their alerting system was meant to send an email, but couldn't send an email due to DKIM failures. So they just thought, we don't have any alerts, so that's fine. These are the sort of things that only really discipline and standard can work around. And that's why you need your own individual team that can work on this. So let's talk about some exquisite stuff now. Have some fun with this, I guess. So the first one is some of the benefits that we have from implementing good visibility, good monitoring, and good reliability, because all of this is not just about theory and enforcement. It's also about being able to really open up with integrity about what you're doing. So obviously I'm not going to be sharing anything from clients. So what I'm going to do is my own little network and stuff at home. Obviously I've got my my good fun bits here, but I've got my own servers and so forth, and I've got a dashboard that monitors them. And you folks who have never seen my server infrastructure have no idea what I've got. I'm just going to show you my Grafana dashboard, and I think in about 4 or 5 seconds you can probably tell me what's going to be an issue. there's a great big red box in the middle that says DPC cert expires in 6.4 days. And it's still due to expire, actually. I need to fix it. But the bottom line is, that's valid. That's integral alerting. And it's not just telling me that that's going to be a problem. It's giving me forewarning, as well as letting me know when it's not a problem. So can I rely on this dashboard? Can I rely that the cert's going to be going down soon? Yes, because the boundaries for failure are so far away, because I can already tell, like, look, my internet's online. I've got the actual service itself, and the services that use these certs are there. We've got all the CPU and the memory, so the machines seem to be online. And then we've got this one particular certificate, which is currently meant to be going down in 6.4 days. And it's regularly ticking down. It's now at 3.23, so I should fix it. But once again, that's my problem, and you guys all know about it simply from looking at a dashboard. So a bunch of people, essentially technical, non-technical, could tell me exactly what's going to go wrong. I'm going to have a certificate expire from simply looking at a dashboard, and you know who to go to. And that's the sort of reliability that we're looking at building in. Really honest, really to the point. And when it will tick over in 3 and a bit days, if I don't replace it, it's my fault. Ownership there too. I did have a client the other week who didn't have their certificates monitored, and it failed and lost the whole office for a day. And if you don't have anything like this, once again, it's harder to put that standards and responsibility there. Let's do another example. This one is similar to GitLab. So I've got databases. Those databases need backing up. And here's a little message from the chatbot to say that things are backed up. How can I rely on this? Well, for starters, it's told me how many files are in there. It's not just telling me, yeah, the backup script worked. It's gone, I've backed up. I had a look before I backed up. It had 8,000 odd files in it and about a gig of memory. And this is backing up my entire code and repos encrypted to AWS S3 bucket. So it's an offsite backup. It's done it at 1:05 in the afternoon. So that's kind of standard. You might be thinking, it sounds like it runs daily. And you're right, it actually runs every 12 hours. But what it does mean is that if I don't get a message every day telling me that the backup's done, does it get a bit spammy? Yeah, it can do. But I definitely notice when the backup's failed, or possibly the chatbot's down, or I've got some other problem somewhere. The alerting is not just for bad alerts, it's also for good alerts as well, to make sure that everything's up and functioning correctly. And it's things like this that change the kind of methodology of how you approach. It's really delving into the why this, why that, how do I know, and to really question and encase things, and to get things really visible, really secure, so that ultimately we as people can rely on them. So after all that sorted out, we've talked about some basic stuff. We've talked about backups, monitoring, alerting, but the really, really good stuff, the truly exquisite stuff, is where you have problems across your organization which need standardized approaches, engineered approaches to it. So a classic is PII data and leakage of secrets. So I'm sure if you haven't seen passwords in logs, you probably had a really idealized career, but I see passwords in logs all the time. And all it takes a lot of times for someone to turn debugging on, and you get passwords in logs, you get people's email addresses and everything else. That's a common issue across all teams. So can you rely that when you're uploading things to your cloud provider who are not going to be wanting just random email addresses in their account, can you rely that that's going to be captured? Well, you need a centralized solution. And yes, this is where excellent SRE can come in. You've covered all the low-hanging fruit. Now you can start engineering optimized solutions. You can start saying, we as a company need to rely that we're not just leaking data. Well, here's a scanning job. We go through the entire logs, and whenever anything finds any PII in tests or anything like that, matching our regexes for email addresses and phone numbers and the like, we get an alert and we flag it. And if anything picks up in prod, we purge it, and we purge it properly. And then we also get alerted as to the general details without emailing the problem around and making it worse. Can we make sure that our endpoints are not getting compromised? Well, yes, we can put a standardized solution. Most of us are running Linux servers. Most of us are running something else. So we can have a standardized honeypot. We can have alert logins for SSH. We can make sure that we got port scanning. We can have some really, really good standardized engineering approaches where nothing gets released unless you've got a beautifully secure server with honeypotters, capture activity, you're exporting the logs, and you're making sure that if any of those logs have PII data in them, that you're getting alerted to it so you can go back and check that you're not leaking customer details. And that one's going to become more and more important as governments get more and more over you on like GDPR and everything else. So that's going to become even more important. And then even business aspects such as how are we inside our SLA? It's a constant query I've heard. Can we check the uptime? And the answers aren't always as good as they should be. We should have our active continuous monitoring, but not just of standard things like are the servers on, do we get our health checks back? You should have things like synthetic users. So you should have users, test users, they exist all the way out to prod, and you definitely need the discipline and the hygiene to do that in prod, but you should have it in prod who can be created, do whatever they need to do, the full workflow, and be successfully destroyed. And you should have those transactions and timings all the way through. You should be testing exactly what your users are doing. And that's really important as well. And then you can confidently respond to issues. You can have conversations with your suppliers where you can go, and even your sales teams can go, nope, this is how it works, and we have a massive uptime. And if you do it and you find that you don't have a massive uptime, congratulations, you just found a load of areas in which you can improve your business and get to the point where you can get out there and really start competing. So I've mentioned Google's SRE books. When I read them, there was only one of them. They've gone into a trilogy now, so you can give them a go. I think they're quite good. I think they're at a lower level, more of a lead. But there's one book which I really, really enjoy, and I think it encapsulates this whole concept and how you should approach SRE brilliantly, and that's Black Box Thinking by Matthew Syed. So that talks about the success in the aviation industry in making planes reliable, i.e. not having them crashing. Would you catch a flight if there's a 10% chance it just falls out of the sky? And the answer is no. And flying a plane is now much safer than driving. And that's come purely from taking this engineering methodology, being objective, getting to the bottom of things, ownership, and make sure that we've got multiple fail safes to know what's going on. That actually makes it okay to stick 2, 3, 5 tons of metal into the sky. So that's a brilliant book that goes into that methodology. It's also quite a nice read to get away from the constant tech books and examples. And it's good. It's just a brilliantly read book. So make some time for that, I would say. You'll enjoy it. And overall, I'd just like to say, look, some of the best thing about SRE is the fact that because you're engineering solutions, the solution never goes away. You always end up with that solution. I've not had to worry about backups for literally years now because it just happens. And I have restored from those backups as well. So I'm comfortable, that's reliable, brilliant. It's a solved problem. So you can do that. You can get your low hanging fruit. If your principal engineers and your SREs already know the problems, they almost always do. You can just give them the breathing space to get on with it. But because they're quite common problems, especially the low-hanging fruit, you can actually just burst your resource with additional resource or a WeShape squad or someone like that. Get them in, knock out all the easy stuff, and then you're left with the more challenging things that will be able to, you'll potentially get your application teams or other people, SREs and PEs to deal with, or you can carry on with that. But the solutions that you put in, at least at the very beginning stage of SRE, never go away. PII information going everywhere is never going to go away. You're never going to not want backups. You're never going to not want to be able to rebuild your entire estate. Those are all really important things. Health checks are here to stay. So if you can get that in, and a lot of this as well is documentation process. So if you can get that in, you get your documentation and process done, sorted, then that frees people up, gets rid of a lot of that toil, a lot of that incident support and everything else. And that doesn't necessarily need to be off your team. Once it's in, it's in. The only thing you do need is discipline, but everything else, absolutely fine. And the other benefits as well is like, look, once you get this in there and you have this hygiene and this discipline, everything else that's coming down the pipeline is going to be a lot better. So you've got the 27K01, which is on a lot more and more pitch decks and a lot of other things. It's a requirement for business, a requirement for partnerships. If you've got this discipline and if you've got this documentation, standards, procedures, that's going to be a cakewalk compared to what it would be if you just have everything be Wild West. So that's going to be better for your business, both at a strategic point of view, but also monetarily as well, because you'll be outperforming your peers. It's a better working environment as well. Being on constant firefighting is absolutely horrible, and you will lose some of your best resources. SREs, good SREs, are highly experienced engineers. They've seen a lot of stuff. These are the guys that you call when things have absolutely gone to the worst case scenario. They're your best. And if they're walking out the door, they're taking the domain knowledge as well as the ability with them, and they're not easy to get a hold of. So you want to keep that environment good. And if it's good for SRE, it's also good for everyone else, because SRE generally tends to get the brunt of things. You don't get your application teams together anywhere near as much as SREs for incidents and other things that really make for poor working environment. And then when it all does happen and it all goes really badly, you can recover because you've been through the drills, you know it's there. And it also leads to a better relationship with your clients. When they chase you, go, when are we back online? It's like, well, we've had a massive incident, Amazon's gone down, but we're just migrating everything over to a different region. And because of that, we estimate in 2.5 hours we'll be back online based on the drills we've previously done. What a beautiful response as to, I don't know, I talk to the development team. It's far better. And then that improves your bottom line, because if clients don't leave, well, you're going to keep that revenue. So explore your options of where you can go with it. Check out the sort of problems that your team might know about and might want to get sorted. You probably already do, but it's always good to check and explore what you can do to really get some engineering done. And that could be inside your company, could be outside of it, but once the solution's in and it's a well-made solution, it stays and it keeps providing those benefits. So any questions or queries?
As I mentioned, any questions or queries for WeShape as a whole as well, feel free to ask on here or reach out to us afterwards as well. Can you see? Cool. There we go, Andrew. I believe there's a question down in the chat, so it should be at the bottom of the Zoom. And Chris.
Okay, let me exit this. I believe I need to go to a different tab for that.
Oh, sorry, Andrew. I can read it if you'd like. Want to jump back in?
Yeah, read it to me. That'd be even better.
So Chris is asking, how do you strike the balance between good enough and gold plating solutions?
Reliability. So what you want, what you consider reliable. So there's a risk assessment that goes on where you go, okay, what's the likelihood that say you've got a data supplier, well, we just use Amazon because most people know that. You run all your machines in one availability zone in Amazon. So you've got one availability zone. What happens if that goes down? That goes down quite often. You often see Amazon having problems with that. Okay. So what we'll do is we'll engineer up so it runs multiple availability zones. And then you do that and it's, okay, so what if the whole region goes down? And that has happened before. Okay, so now we want to do cross region. And what you find is a lot of people do cross availability zones quite easy. So a lot of people do that. Do cross regions a bit harder. So most companies, I say, don't do cross region. And then you've got to go, well, what about Amazon as a whole? Because don't forget, you've got Route 53, you've got other global services that are more or less hosted out of US East 1. So what about other suppliers? And this is where you get things like CDNs will run cross infrastructure suppliers. So there's an element of risk appetite, and that's where your good enough and gold plated comes in. I do believe that overall, you would know where you sit. If you're a bank or if you're an insurer, you've got to get a gold plated. You've got too much regulatory oversight to do a half job. If you're an application supplier who provides something that's cached or can be backed up, and it will be a few hours of downtime, but it fits within your SLAs, you don't need to worry too much about it. You do good enough. And that's that risk management curve, which I'm sure a lot of people know of really outside of IT as well. But that's what I would follow. And that's where it comes into the hard questions as what's our actual requirements? When do we get sued? And what do we want to be, and when's it good enough? It's being able to draw that line.
Perfect. Thanks for that, Andrew. Hopefully that answers that question. We'll just do a final call. Any other questions if you want to put them through in the next sort of 30 seconds or so, and then we'll wrap everything up. Whilst we give everyone a bit of time, if you want to move to the next slide, Andrew. Perfect. So again, in the year of COVID, classic QR code, do scan it and make sure you reach out to us. Also worth saying, in the next week or so, do keep an eye out on the social channels. We'll be posting the highlights. Also keep an eye out on your emails. So we'll be sharing around this full recording for you to watch back over again. Also share around with your teams and get their feedback. Hopefully you've all come away from today knowing that bit more about SRE. And yeah, once again, big thank you to you, Andrew. Really appreciate this, and hopefully everyone's enjoyed.
Yep. Any questions or queries, just reach out and we'll be more than happy to go over it.
Absolutely. It's worth saying, if you email them to hello@WeShare, we can get Andrew and he'll come back from there.
Yep.
Perfect. There we go. Thanks so much, everyone. We'll just give everyone a couple of minutes, and then, yeah, hope to see you with the next one.